All right, so this next topic we're going to talk about is dividing rational functions. So when we divide, we're actually going to figure out what the best method is. So sometimes we can simplify and then divide, or we can go ahead and write it as one fraction, where that's what we're going to do with this one. So yes, the square root of 9 is a perfect square, but we're actually going to save ourselves a lot of time and effort if we go ahead and just write this as a single square root. So if we write this as the square root of 45 over 9, then we can go ahead and do 45 divided by 9, which would be 5. And we know that 5 is a prime number and we can't simplify anymore, so that would be our final answer. All right, so looking at this next one, 4 over 49 is not a pretty number. It's not going to simplify to anything that helps us out, but I do recognize that 4 and 49 are both perfect squares. So we're going to go ahead and split this. So we're going to make it the square root of 4 over the square root of 49. So since those are both perfect squares, we can just go ahead and take the square root of 4, which is 2, over the square root of 49, which is 7. We can't simplify that any further, so we're going to go ahead and say that's our answer. All right, so for number 3, you could do this one either way. Because 40 and 5 divide evenly into each other, I'm going to go ahead and write it as one fraction and do 40 divided by 5. So 40 divided by 5 is going to be 8. So once we get here, we need to decide if we can simplify this any further. So the square root of 8 can be simplified. The biggest square root that we can divide it by, or sorry, the biggest perfect square would be 4, and we'd be left over with 2. So if we go ahead and do that, we know the square root of 4 is 2. And the square root of 2, we can't simplify that anymore, so that would just be our final. All right, so this next problem is gonna be easier to go ahead and simplify separately, because if you notice this bottom part, so this denominator, is actually going to simplify pretty cleanly. So if we look at the bottom, 4 is a perfect square, so we know that we can pull 2 out. We have x squared, which it is also a perfect square, so we can pull 1x out because we can just do 2 divided by 2. And then we have 6y, so we can go ahead and do 6 divided by 2, and we would get y cubed. So for the top, we need to figure out what our 2 perfect squares would be, or sorry, what would our 1 perfect square be that we could divide 40 by? So that would be the square root of 4. 40 divided by 4 is 10. So when we write that on in our fraction, we have the square root of, the square root of 4 is 2. And then we have the square root of 10, which is just going to say the square root of 10. We have 1x on the inside. That's just going to stay there. And then we have 4 y's on the inside. So if we do that, we're going to do 4 divided by 2, which is going to be y squared. So then from here, our radicals are completely simplified. We want to simplify the fraction. So we have 2 over 2. That's going to cancel out. We have 2 y's up top and 3 on the bottom. So these 2 are going to go away, and we're going to have just 1 left on the bottom. So notice that I didn't say anything about these 2 x's we have left. So if something is inside of this square root and then something's outside on the bottom, you cannot simplify them. You can't cancel them out with each other. So we just leave it like that. Oh, and I forgot my y. All right, so for the next one, we are going to go ahead and you can do this multiple different ways, but I'm going to go ahead and just divide everything first, and then I'm going to simplify what I can. So 48 divided by 64, that's going to give us 3 over 4. So we have 6 x's on top, 2 on the bottom. So when we subtract those exponents, we're left with 4 on top. And then we have y cubed up top, y on the bottom. So we're going to have y squared left on top. So once we do this, the best move is to split it up. So we have the square root of 3x to the 4th y squared over square root of 4. So then let's simplify the top and simplify the bottom, and then we should be done. So we have 4 x's on top, so we're going to have 2 on the outside. We have 2 y's on top, we're going to have 1 on the outside, and we're left with the square root of 3. And then the square root of 4 is going to be 2. So that would be our simplified answer. All right, and finally for our last one, again, this is kind of like you can decide if you want to divide first or if you want to simplify each thing separately. So this one, I'm going to go ahead and divide them first. So I'm going to do 48 divided by 3, which is going to give me 16. And then I'm going to simplify my variables. So I have 3 x's up top and 1 on the bottom. So we're going to have 2 left up top. And we have 4 y's on top, 2 on the bottom, so we're going to have 2 left up top. So this actually gives us a pretty clean expression. We don't have a denominator anymore, so we can just go ahead and simplify that. So the square root of 16 is 4. We have x squared, so when we divide that exponent by 2, we're just going to be left with 1. And same thing for our y. So that would be our final answer. All right, so that's it for dividing. So you can go ahead and try the next 3 on your own and check your answer on Schoology. The next thing we're going to do is kind of what happens when we have a radical left over in the denominator. So mathematicians do not like the radicals in the denominator. So we need to do a process called rationalizing the denominator. So what we want to do is multiply the numerator and denominator by the radical in the denominator. So if you look at number 1, there's a square root of 2 in the bottom. So what we have to do is multiply by the square root of 2 on the top and the bottom. Once we do that, we're just going to multiply like we learned in the previous video. So we have technically a 1 on the outside. So we're going to do 3 times 1 and get 3. And then we're going to do 3 times 2. So we multiply what's outside of the radicals and what's inside, and we're going to get 6. And then on the bottom, we're going to multiply what's on the inside, and we're going to get 4. So what should happen is that you're left with a perfect square on the bottom, and you're going to end up with 3 square root 6 over 2. So simplify up top if you can. We can't on this one, so that would be our final answer. All right, so for the next one, let's simplify this number first. So we have 15 divided by 3. That's going to equal 5 on top. And we have the square root of 5 over the square root of 7. So we're going to go ahead and rationalize this. So the square root of 7 is in the denominator. We need to multiply by that. So let's go ahead and do 5 on top. And then we have to do 5 times 7 underneath the radical and get 35. And then the square root of 7 times square root of 7 is just going to be 7. If we can simplify that anymore, we need to, but we know 35 isn't going to have a perfect square in it, so we're just going to leave it like that. All right, so same deal for number 3. We're going to go ahead and multiply by the square root of 12 on the top and the bottom to cancel out that denominator. So on the top, we are going to do 12 times 7. That's going to be 84 over 12. So now we need to simplify, because we can simplify the square root of 84. So we can divide that by the 2 perfect square, or by 1 perfect square, and that's just going to be 4. 84 divided by 4 is going to be 21. So our final answer is going to be 2, because the square root of 4 is 2, square root 21 over 12. Sorry, we're actually not done yet because we have 2 and 12 that we can simplify. So that's going to simplify, and we're going to be left with 6 on the bottom. All right, so for the next one, now we have variables in play. So we're still going to be following the exact same process. Since we have square root of 2x on the bottom, I'm going to go ahead and multiply by that on the top and the bottom. So we're going to have 2 on the outside, square root 14, and when we do x times x, we're going to have x squared. Over, and on the bottom, we're just going to be left with 2x. So whenever we rationalize, your denominator should be the whatever was inside of your radical the first time. So 2x on this problem. So now we can simplify. So we can simplify the radical up top. We have 2x's on the inside, so we can go ahead and pull one out. 14 isn't divisible by any perfect square, so we can just leave it like that. And then we have 2x on the bottom. So now that we've simplified, we have 2x on the top and the bottom. So those are both going to cancel out, and we're just left with the square root of 14. All right, and last one, we're still doing the exact same thing. So we're going to go ahead and multiply by the square root of 3x on the top and the square root of 3x on the bottom. So we have the square root of 15, because 3 times 5 is 15, x cubed over, and then on the bottom we'll have 3x. So we need to decide if we can simplify this any further. And because we have 3 x's on top, we can go ahead and pull 1 out, and we're going to have 1 left inside the radical. And then we're going to have it over 3x. Then our last step would be that we can cancel those x's out, and we would do square root of 15x over 3. And remember, we cannot do 15 divided by 3 because it's the square root of 15 on top.